Hello students, good morning and how are you doing? This is your chemistry teacher, Ms. Adana Ogu. Hope you have been staying safe and you have been studying your book as well. We have to come to you this way due to the coronavirus pandemic. So you have to do all that you have to do. Study your book and make sure you do what you need to do. Much as you play, you must also take out time to read your books as well. All right, so today I'll be taking a topic in chemistry for SS2. Now, the topic I'm going to treat have already been sent to you via the school website, and that topic is water. Now, I need to mention here that the notes for this topic have been sent to your website, that is the school website. I'm sure you've seen it and you have started copying and looking the assignment. But peradventure you've not done so, please, by the end of this class, you should be able to understand it and able to attend the assignment that will be given to you. Now, in this video, I'll be treating week 1 and week 2 topic. Now, you agree with me that the topics are related because it has to do with water, everything about water. So, let's go on. At the end of this class, you should be able to learn some specific things. That's your learning objective. So at the end of the class, you should be able to state or mention the uses, sources, and types of water. You should be able to state the causes of water pollution and their effects. You should be able to explain the process involved in the treatment of water for public use. You should be able to understand the structure of water. You should be able to state the chemical properties of water, test for water, define hardness of water, state its causes and methods of softening hard water. Then you should be able to state the advantages and disadvantages of hard and soft water. So let's continue. Water. I'm sure you can all relate with water. Water is a substance we use every day. We drink a lot of water for washing, for cooking, for taking our baths, for washing our clothes, and a lot of other uses we use water for. If you use the toilet, you have to flush with water. So water is like the common saying, they say water is life. Water is indeed life because every day we use it. Even from research has shown that you cannot do with water for more than 2 months. It can lead to death. If someone does not get water to drink for more than 2 months, the person can die. So water is very important. Now we look at types of water. Water is of 2 types. We have natural water, that is water from natural sources like rivers, streams, ocean, sea, lakes, and any natural bodies known as natural water. Even well water is a natural water as well. So these are natural water. Then you have treated water, water that is treated for specific use. For example, distilled water is treated so that it can be used in the laboratory, majorly used in the laboratory. Then you have your pipe-borne water. These water are treated for public use. Now, I need to mention here that the purest form of natural water is rainwater. That's, rain, when rain falls to us, is the purest form of water because rainwater is actually formed as a result of evaporation of water from the sea, from the ocean, from when the rain itself falls, sometimes you have water then evaporate and go into the atmosphere. So it condenses back and fall back to us as rainfall. Now, while the water is evaporating, every other impurity that is contained in the water is left behind. So the only form of water, the only thing that goes up there is purely water. And then That's what condenses back and fall back to us as rainfall. Then for treated water, the purest form of treated water is distilled water, which is commonly used in the laboratory. So rainwater is a natural distilled water. So I hope you understand that. So that is for types of water. Then now we go on to water pollution. Water is said to be polluted when it is unfit for the purpose it is meant for. I'll say that again. Water is said to be polluted when it is unfit for the purpose it is meant for, or water is said to be polluted when it is contaminated with harmful substances. Now, look at this. Look at this. Look at this. Can you see this? Most times, water pollution is actually caused by indiscriminate dumping of refuse into water bodies. Look at this. You see, a lot of times we use sachet water, a pack of sachet water, bottled water, and stuff like that. Look at them. This actually cause a lot of havoc in the water body, thereby polluting it. You agree with me that in this image, whatever the water here is unfit for any purpose actually. So you might not be able to use it. Now, look at this. Sometimes this is water like seaway or sewage being drained into water body. So when this sewage gets into the water, it will pollute it. So you see some people from their homes, they connect their sewage directly into water bodies, into the drainage, and this drainage flow into water bodies, so thereby polluting it. Now, look at this image here. You see, the fishes are dead because the water is polluted. Like oil spillage is another example of causes of water pollution. So the causes of water is actually indiscriminate dumping of refuse into water body from industrial effluents, industries. They allow their waste to flow into water bodies, untreated sewage flow into water bodies directly, oil spillage, that's common in the riverine areas or the Niger Delta where oil is being drilled. So the water is polluted by oil spills in the water body. Then you have agricultural waste from fertilizer, overuse of agricultural products, fertilizers, insecticide, herbicide. Now they are washed into water bodies, thereby polluting water. So the effect goes from the world have recorded that most deaths are caused by diseases from water, waterborne diseases like typhoid is caused by water pollution. Then you have cholera caused by water pollution, and so many other diseases. Even sometimes some fishes that we buy, because they contain, for example, look at this image here. You see the fish. Some of these fishermen or those people that want to make money, they would take this fish and just maybe make it look nice and sell it to people, and people eat it and get some diseases from this water. So water pollution is a major problem in the society, and we as individuals, we need to look at the way we dispose our refuse. We should dispose them properly and not drop waste or refuse anywhere. So we should be able to play a role in controlling water pollution. Now, next on today, we are going to look into municipal water treatment. That is treatment of water for public use. Now, look at this image. The process involved is that raw water reservoir, that means water from various sources, from river, from rain. Now, rainwater, remember I mentioned that rainwater is the purest form of distilled water. But when this rainwater is falling to us here on earth, usually we have channels by which we get this water so that we can keep them. Maybe via the rooftop of our houses. Now, you agree with me that there are many materials on top of the roof. So while water is falling, it will wash off those things that are up there, and it will go along with the water that is collected for reserve. So the water becomes polluted, although it was very pure, but because of the channel through which it is collected, it becomes polluted. So to treat water, usually water is collected from various sources, from streams, from rainfall and other sources. So it is stored then as in it is stored in raw water reserve. So they are stored. You have the raw water reserve, then you have pumping station. That means you can pump the water. Then you have what is called mixing tank. Now, a mixing tank is a big tank where you do mixing with aluminium sulfate, alum, sodium aluminate, colloidal sulfate, calcium, or bentonite. These are substances that are used are put into the water so that those waste that are inside the water will form big clumps. That is the process by which, when these substances are put into this water, it mixes with them and form big clumps, and that process is known as flocculation. So it forms big clumps, which then, when the next process is that you put it into settling basins. Now, those big clumps that are formed settle down at the bottom of the basin. So the clear water is now at the surface. Then next thing you do is to pass it through a sand filter. So filtration now happens. So you see now, while it's going through the sand filter, those big clumps from flocculation, those flock or clumps that were formed will now be left behind in the filter, while the clear water goes through the sand filter while filtering. So next thing is chlorination. That means chlorine is added to disinfect the water. Now, we know from previous studies, we know that chlorine is a poisonous substance, but it is used in treating water because a calculated amount of it is added to the water so that it will kill any germ. So chlorine is a germicide. That means it kills germ. Only calculated amount of it is added. If excess of the chlorine is added, it can become poisonous. So a calculated amount is added to the water to kill any germ that might be present in that water. Then the water is passed to the storage reservoir and then supplied to the consumers, that is the public, for use. This is how water is treated for use in this society. Now, next, we look at structure of water. Now, water, as we know, water is very important in chemistry because it is known as a universal solvent. What do we mean by universal solvent? Water dissolves almost anything. So it is used to dissolve substances in the lab so that chemical processes can take place. Now, look at this diagram we have here. This is the structure of water. Now, water is known as a polar substance because it has partial charges. Now, you know that oxygen is a very electronegative element which attracts electrons to itself. Now, hydrogen that is in water is H2O. Like, you can call water the oxide of hydrogen. Now, this oxygen attracts electrons, pulls electrons towards itself. So because it is pulling electrons from hydrogen, it becomes partial negative and hydrogen becomes partial positive. Such substances that have partial negative charge and partial positive charge are known as polar substances. Unlike ionic substance will pull the electron from the other substance, completely pull it away. For example, um, in sodium hydroxide, for example. Sodium will completely give out its electron to oxygen, and oxygen will accept it. So that's an ionic compound. But in this one, polar substances is that the one of the substance is partially positive, while the other one is partially negative. So that's what we refer to as polar substance. Now, another thing you should know about the structure of water is that it contains hydrogen bonds. Now, we've talked about types of bond when in our SS1 class. Hydrogen bond is the bond between one hydrogen atom and a very electronegative element in one molecule of another compound. Look at this, for example. You have high oxygen. Oxygen with this dotted line. This dotted line is showing that this dotted line means hydrogen bond, while this straight line is covalent bond. Now, this dotted line is between one oxygen atom in one molecule of water and hydrogen atom in another molecule of water. Look at it in this same one, oxygen, another hydrogen atom in another molecule, one molecule to another hydrogen, another molecule of water. So now, what is the importance of this structure of water? Because of the polar nature of water, it makes it able to dissolve other polar substances, and it can dissolve almost anything, like I said before. Water, most ionic compounds all are soluble in water because of the polar nature of water. And water also dissolves other polar substances, like ammonia is a polar substance. So water dissolves it. So because of this nature, water can dissolve anything. Now, in terms of hydrogen bond is what makes water to have high boiling point. Now, for the molecular mass of water, the molecular mass of water is 18. But compare it to other substances which have even higher mass than water. They have low melting and boiling point, but water has high melting point of 100 degrees centigrade. So it's due to this hydrogen bond. Now, another thing that the hydrogen bond plays is that it helps in floating of ice in water. Now, in physics, you know that a substance that have high density will sink in water, but ice floats in water because of the presence of hydrogen bond. So that's the role that hydrogen bond play in water molecule. It makes it have high melting and boiling point, and also makes ice to flow. Now, the importance of ice flowing is that, for example, in those temperate regions where they have things can easily freeze, water can freeze, it actually prevents aquatic life from dying because the ice is flowing, so it's not sinking. If it should sink, it will freeze the aquatic animals to death. But because they are floating, it does not really have effect on the aquatic animals as much. So this is very important. That's why water is very important, and it has those structures. Now, next, we look at chemical properties of water. Now, water reacts with metals depending on their position in the electrochemical series to give off H2O, that's hydrogen gas. Water, like we know, most metals, those metals that are more electropositive than hydrogen in the electrochemical series, can be displaced, can displace hydrogen from any substance. So let's look at example. For example, sodium, potassium, and calcium will react with cold water to form alkaline. So you have calcium reacting with water to give you calcium hydroxide and alkaline, and give up hydrogen gas. So cold water is what these metals, which are sodium, potassium, and calcium. But look at the other one, magnesium and zinc will react only with steam. Hope you are getting it. Now, sodium, potassium, and calcium are more electropositive than magnesium and zinc. They are the top of the electrochemical series, so they can react with cold water to give alkaline and hydrogen gas. But magnesium and zinc, which is after this other three elements, will react with steam. Steam is the gaseous form of water to give the oxide. That means to give magnesium oxide and zinc oxide, and then give off hydrogen gas as well. Then next you have iron. Iron is lower, is a little is after magnesium and zinc, so it reacts with excess steam only when red hot. That means iron will be red hot, and it will only react with excess steam when it is very red hot. Meaning that if iron should react with cold water, the reaction will not occur. If iron should react with steam when it is not red hot, the reaction will not occur. So iron will only react with excess steam when it is red hot to form this oxide of iron, which is Fe3O4. This is an oxide of iron. So these are the chemical reactions of water. They react with melters depending on their position in the electrochemical series. The most electropositive metal will react with cold water. But those following the sodium, potassium, and calcium will react only with steam. So that means that magnesium and zinc will not even react with cold water. But now, let me mention here that sodium, potassium, and calcium, when they react with steam, it can be very dangerous. It causes the reaction becomes volatile, and it can cause irritation of skin or corrosion of the skin. That's why you react it with cold water, not with steam. I hope you got this. Magnesium and zinc will only react with steam, but with cold water, the reaction will not proceed. Then iron will not react with cold water, neither will it react with steam just like that. The iron needs to be red hot, and then it can react with excess steam. Those are the chemical properties of water. Then I need to mention here that copper, gold, silver, and mercury, those ones are after hydrogen in the electrochemical series. They do not react with water in any form. So if you react them with water, whether steam, whether the copper and the gold and what or the rest of them become red hot, the reaction will not proceed. The reaction does not. That means copper, gold, silver, and iron do not react with water in any form. Now, next we go to test for water. How do you test for water? Now, you agree with me that water is colorless. That is, it is colorless. It does not have odor. It is odorless, and it's tasteless as well. So if you go into the laboratory, maybe you get into the laboratory and you saw a substance. Now, you agree with me that acid is colorless as well, and it's odorless as well. So how do you know that this is water and this is an acid? For example, you come to the laboratory, on the bench, you saw a substance in a beaker, and you don't know what it is. The first thing you need to do is to test with a litmus paper. Water is neutral to litmus paper. Hope we are getting it. Water is neutral to litmus paper. So when you test for this substance and it is neutral to litmus paper, you might think, okay, this is water. So actually confirm that that is water. You need to test it with white anhydrous copper 2-sulfate 6. Now, anhydrous means that that substance does not contain any water of crystallization. I hope you understand what water of crystallization. There are some substances that have water of crystallization. Such substances like copper 2-tetraoxosulfate 6, tetraoxosulfate 6 can be hydrated. Now, anhydrous means that it has no water of crystallization. It has lost all of its water of crystallization. Now, if you add a few drops of that anhydrous, which is white, in that substance. Let's say you add from that your beaker, you add a few drop of water to the white anhydrous copper 2 sulfate, it will turn blue. Now look at this. You have your copper 2 sulfate, which is white, and water, a few drop of it. Now the copper 2 sulfate becomes hydrated and turns blue. So it becomes blue. Hope we are getting it. So that tells you that that substance is water. Next, another way you can test for water is that water turns copper 2 chloride to pink. You have a blue copper 2 you have blue copper cobalt, sorry. You have blue cobalt 2 chloride. So it will turn it to pink. Now, look at this that I have here. You have a blue substance, a few drops of water will turn it to pink. So that will confirm to you that that substance is water, and then maybe you can use it for whatever you want to do. So, but once you test the water with a litmus paper, probably it turns blue litmus to red, you know that that is an acid, so there's no need to do this. But once it is neutral to litmus, any of the litmus, whether blue or red, so you should be saying, okay, probably it's water. But remember, salt also are neutral to litmus paper. Some salts are neutral to litmus. So to confirm that that substance is water, you need to test it with either white anhydrous copper, copper 2 sulfate, which turns it to blue, or you test it with cobalt 2 chloride, which turns to pink in the presence of water. I hope we are getting this. Then now, remember I told you that we are treating week 1 and week 2 topic. We are talking about hardness of water. Now, hardness of water, when we say hardness of water, it's not like, is it that water becomes like a stone? No. When we say water is hard, the water is said to be hard when it does not form leather with soap. Now, look at this image. You see this image here. The person is trying to make sure that the soap lathers, but it does not. You are seeing something like something white is there. Those are called scums. SCUM. These are scums. So water that does not lather with soap is known as hard water, and it's due to the presence of some substance. Now look at this other image. You see, for the first one, the water lathers. Then the second one, which is hard water, you see scum on top of the water. So this is what we know, that's the definition of hard water. Hard water is water that will not lather with soap. Now, what are the types of water? Water hardness of water is of two types. We have temporary hardness and then permanent hardness. Now, hardness of water is caused as a result of some dissolved substances inside water. Now, for temporary hardness of water, the substance that causes temporary hardness of water is calcium hydrogen thiazocarbonate 5, which is CaHCO3. So temporary hardness of water is caused by this substance, calcium hydrogen thiazocarbonate 5. Then permanent is caused by either or both of these salts, calcium tetrahydrosulfate 6 and magnesium tetrahydrosulfate 6. That's magnesium and calcium salt of tetrahydrosulfate 6 causes permanent hardness of water. Now, why is one referred to permanent and the other one referred to temporary? Now, it's because for temporary hardness of water, calcium hydrogen thiazocarbonate 5, which causes temporary hardness of water, can easily be decomposed by boiling. When you boil any water that contains any water that contains calcium hydrogen thiazocarbonate 5, it breaks down to calcium carbonate, which is insoluble in water. Remember that this calcium hydrogen thiazocarbonate 5 is soluble in water. So when it is boiled, it becomes insoluble, and then it can leave the water body. Now, I'll give you an example. Sometimes when you boil water, you see that the kettle, at the end of the day, you see white substances in some, when the water is hard, you see white substances like what you saw in that image that I showed before. In this, you see something like this at the top of the kettle. So that is come because temporary hardness of water can be broken down by boiling. So that's why it's called temporary. But for permanent hardness of water, it cannot be broken down by boiling the water. So I told you that temporary hardness is caused by calcium hydrogen triazocarbonate, while permanent is caused by either or both calcium tetraazosulfate 6 or magnesium tetraazosulfate 6. So let's look at how we can soften hard water. That means when we say soften, how can we turn hard water to become soft water? Now, remember what soft water is, simply means that water that can lay down with soap. So now, temporary hardness of water, I've said the types. So we go into methods of softening water. Boiling. Remember I told you that temporary hardness of water can only be, that's why it's called temporary, because boiling can break down that salt that is dissolved in the water to give us this calcium carbonate, which then becomes insoluble water, and then you can filter off this calcium carbonate and get your soft water. Then next method of softening hard water is addition of slake lime. Slake lime is calcium hydroxide. Slake lime is calcium hydroxide, and so calcium and this method is only applicable to temporary hardness of water. So it converts the calcium hydrogen triazocarbonate 5 to calcium triazocarbonate, which then you can also filter out from the water and get your salt water. Then next, we have addition of washing soda. Washing soda is calcium carbonate, calcium triazocarbonate 5. Now, this method is applicable for both temporary and permanent hardness of water. So you see now, the salt that causes temporary permanent hardness of water reacting with sodium triazocarbonate gives you, do you see calcium carbonate, which becomes insoluble? You filter it off and then you get your soft water back. Then here you see calcium hydrogen triazocarbonate, that's for temporary hardness, reacting with washing soda to give you calcium triazocarbonate 5, which is insoluble, and then you filter it off and get your soft water. Other method of softening hard water is distillation and Permutit process. Now, distillation involves boiling the water and then condensing it back. Now, look at the setup for simple distillation. You have water, then a heat source boiling. So when the water boils, you connect it to a condenser. So while the water is turned into vapor, that's steam, it condenses back as water, and then you get your soft water. This is applicable for both temporary and permanent hardness of water. So those dissolved salt that cause the hardness of water are left behind in this container, while you get your pure, should I call it pure water or soft water? Now, next one is the Permutit process. Now, Permutit process is involved in using sodium xolite. Now, sodium xolite is a complex substance, which is sodium, aluminum, silicon, and oxygen. The name is sodium tetraazosilicate aluminate. That is sodium xolite. Now, I go to your notes. There are detailed explanation. Now, what happens in this Permutit process is that the sodium xolite, which is represented as NaZ, this xolite is actually the aluminum tetraazosilicate aluminate, then react with the calcium salt in calcium ion or magnesium ion in the hard water to give you calcium calcium zollite and then give up hydrogen ion. Now, in this Permutit process, when the Permutit is exhausted or the zollite is exhausted, you can refill it by adding sodium chloride to regenerate the sodium zollite, which is the Permutit. I hope you understand it. So the water becomes soft. Now, if you look at this setup, you have the hard water, source of the hard water, then you have your hard water is inside now. Now your Permutit is in this column. Now when it goes through that column, the water becomes softened, and then you have your soft water flowing out of this outlet, while the waste can flow out of this outlet as well. So when this Permutit is exhausted, you regenerate by adding sodium chloride solution. I hope we are getting this, what I'm saying. So you regenerate by adding sodium chloride solution into the setup. So your sodium zollite will now be regenerated and the process continues. So now we go into advantages of hard water. Now, what are the advantages or what can be benefited from hard water? You agree with me that calcium is useful in the formation of bones and teeth. So hard water contains that calcium and calcium that helps in the formation of bone and teeth. So when we take in hard water, it's not poisonous. Hard water is not poisonous. It's just that it does not allow soap to lather. So when we take it in, it helps in formation of both bones and teeth. It helps animals like snails, crabs that have exoskeleton to form their shells. So that's another. Then another importance of hard water is that, or the advantages of hard water is that it cannot cause lead poisoning. Now, some pipes are made of lead. When you transport hard water through lead pipes, the calcium and magnesium salt dissolved in this hard water will not allow this lead to be dissolved in water. So the water will be transported and will not cause lead poisoning. But for soft water, because it is soft water, it will dissolve lead, and lead is a poisonous substance. So when humans consume it or when it gets to the end user, it becomes poisonous. So that's one advantage of hard water. It does not cause lead poisoning. Then disadvantages of hard water. Now, that one you can relate with it, that hard water will not lather with soap, so thereby it causes wastage, like what we saw in that image. You see, if you try to use hard water to wash your clothes, it leads to wastage of soap, and the scums will be attached to the clothes, so you have to use plenty of water and plenty of soap to be able to actually wash your clothes very clean. Another disadvantage is that it causes fouring of kettle. That means you see scum at the top of the kettle, when you boil hard water, you see scums at the top of it. So those are the disadvantages of hard water. Remember, we talked about water, we talked about the structure of water and their importance, their chemical properties, and we talked about hard water, which is any water that will not lather with soap. We talked about their advantages and disadvantages. And remember, I told you that there are two types of hard water: temporary and permanent. Temporary hardness is caused by calcium hydrogen triazocarbonate, while permanent is caused by either or both of calcium tetraoxosulfate 6 or magnesium tetraoxosulfate 6. So this is where I will end the class for today. I hope you learned something. Please, like I said, your notes are in the school website. Go there and make sure you copy the notes and attempt to do the assignment. But if there's anything that you are not clear about, you can reach me via my WhatsApp, my phone number. You can call me and you can send an SMS. And once I get them, I'll call you back. For my phone number, you know where to get my phone number. There's a WhatsApp group created for your parents. My phone number is there. You can send your message to that WhatsApp group, or you can get my phone number from the school yearbook. It is right there. So you can call me, send me SMS, or send me any WhatsApp message. Thank you very much for listening. I hope you have learned something, and keep staying safe and keep reading your book. Till I come your way next time, I'm Miss Adana, your chemistry teacher. Thank you very much, and God bless you.